Okay, so for the organic chem, right, the introduction, I've taught you before, but fast one. Okay, one more time. So petroleum, right? Petroleum is crude oil is the same. We undergo fractional distillation, right? To get the different fractions, which you need to memorize the sequence, right? Hopefully, Aaron memorized. Aaron, have you memorized the sequence? Very good. Right, so you need to know the sequence. So Jolie slowly start to memorize also. So Peter Pan never play drums like boys. Of course, the fraction that has the lowest boiling point is on top. So the fraction with the lowest boiling point is called petroleum gas. It's used for cooking. All these are like facts. But how to help you remember is the cylinder, okay? It's for cooking. Mainly methane. Mainly methane. Came out before in O Levels, I think. One part of it. Okay, petrol is the one you pump in the car, SO, SPC, right? Shell. Gasoline is another word. Okay, so petrol and gasoline, they are the same. Especially you go traveling, other countries don't say petrol station, say gas station because it's gasoline. Okay. Naphtha is feedstock or raw material for petrochemical industry, make chemicals. Paraffin or kerosene is for aircraft. Diesel is for diesel engine like trucks, right? Some taxi, but taxis are moving towards either hybrid or petrol. Lubricating oil is for making lubricant and wax. Bitumen is for road. And another thing that we learn for road is called molten slag in the chapter of blast furnace. Okay. So the largest molecule is bitumen. So when there's a largest molecule, what thing is the strongest? Since you have any idea, largest molecule, what thing is the strongest? The intermolecular forces of attraction. Okay, because they are all simple covalent. That's all, right? Low boiling points produced first. Okay. Now homologous series. I think later on we look at this. This one, hopefully you can remember. I think Aaron remember already, but the rest of you must remember. Monkey eat peanut butter. So if got one carbon atom, is called methane. Two carbon atom is called ethane, propane, butane. So what happens is that the starting is the same, it's called prefix. The ending, it depends on which homologous series we study. Okay, any questions, please stop me. Okay, then from 5 to 10 is like your math, right? Pentagon, pentane, hexane, heptane. Hexane, heptane, different. Okay, octane, nonane, decane. Give you 1 minute to internalize this thing now. Later on easier. Okay, so now the actual thing is what? So alkane is the first homologous series or the first family that we need to know. Alkane's general formula CnH2n plus 2, we memorize. Okay, means what? You sub the N. So for example, if I give you pentane is C5H12, because C5 then 2 times 5 plus 2. So any number that even C100, then you just H202. Understand? Because you sub in like your math like that, the N to be the number, then you just add the hydrogen. Does it make sense? Actually, it does. So if I give you C5, is H12. If you make sure carbon, or you need to ensure that carbon form 4 bonds, then it's correct. Can you see? H. So to be honest, I know some students, they are particular to hit 12. Okay, they are particular to hit like 12. Okay, okay, erase this part here, misleading. Right, C5, H12. Right, they're very particular, but you need to be particular. What are you supposed to be particular is that carbon need to form 4 bonds, because carbon is group what? Since our carbon is group 4. That's why form 4 bonds. Okay, so your job is to be particular that the carbon need to form 4 bonds. That's all. Then 12 will make sense. Okay, it's just some math that they come up with. So this is called pentane, because 5 carbon and it's an alkane. Alkane, single bond. So they are called, so right now, saturated because they got carbon single bond. Right, it's a carbon single bond. Unsaturated, later you learn carbon multiple bonds or double bond. So this is the diagram for methane, for ethane, for propane. So if you go down, methane, ethane, propane, butane, hexane, hexane, so many, right? Stronger intermolecular force, the same. Stronger intermolecular force, not more bonds, it's all intermolecular force between molecules. I'm not breaking the bond, right? This is for physical property, right? Okay, now viscosity increase. Okay, sorry, go back to that again. So if melting boiling point increase, means go down. So to be honest, some I don't need to remember, but C1 to C4, they are gases most of the time. You understand? C5 to C12, they are like liquid. So can you see that the larger the number of carbon, more than C12, normally solid. So more carbon atoms, stronger intermolecular force, melting boiling point higher, becomes solid. But don't need to memorize this, don't worry. Okay, online student not sure, must type there, okay? Viscosity increase. What is viscosity? The thickness, something like that, right? Like lava is very viscous. So from gas to solid, you must know that solid is very thick compared to gas. See what I'm saying? Okay. Solid is thicker or more viscous than gas. Must know this. Everybody must know this because this is what people stress. If you don't know what is viscosity, you memorize increase or decrease and wrong. You must know that gas is not viscous because it's very easy to flow. Solid is very difficult to flow, or liquid is more viscous than gas. You can think this way. So going from gas to liquid to solid, more viscous. Okay, and the last one that you need to learn. Okay, anyway, all these, there are three. These are called physical properties. Physical properties got three. You need to memorize. Okay, 1, 2, and 3. Flammability decrease. Gas or solid easier to burn? Of course, gas. So the flammability means ability to burn decrease. So please try to understand the English word rather than memorize because you all messed up. So flammability decrease because it gets solid, solid and difficult to burn. Gas is the easiest to burn, you explode. Okay, put these three in your head right now. Any question type there? Isomers. So the next part to this is what? Isomerism or isomers. Right? So isomers are molecules having the same chemical formula but different structure. Like these two are isomers, right? Remember, I think I told you all, I taught you all before. So isomers of butane, actually I shouldn't use the word butane. Isomers of C4H10. I can draw it straight. I can draw 3 and 1 up. As long as carbon form 4 bonds, you will meet 10. You understand what I say, honest student? Okay, so remember last week, or no, I think some 2-3 weeks ago, I asked you to draw the isomers of C5H10. Sorry, no rubbish. C5H12. How to draw? Can all of you try now? Draw the isomers of C5H12 means different structure of the 5 carbon atoms anyhow arranged. Now, so first of all, you draw like that, C5H12. Okay, I just got to draw the C because the rest, I just, for the sake of just putting 4 bond, you hit 12 fine. Okay, don't be particular about the hydrogen. Just make sure all the carbon got 4 bond, it will automatically be 12. Trust me. Second, you make 4, then you drop down 1 now. Yeah. Okay, Jolie understand? So basically, just be simple, make 4, drop down 5. So now you drop down 1, but you don't drop down like that. You drop down like that, you die, it's the same. Same as who? First or second? Same as who? First. Because snake. You know a snake? Look at this. Wow. Wait, back. Snake. This is just one long snake. It's the same as this, right? It's like I have a string or rope or rubber band. I just bend it down. It's the same, right? It's still the same line, right? So these two are the same. They are not isomers. They are the same structure, so cannot this one. Must understand, Then I think Aaron draw something like, wait, I use yours, Aaron draw something like this, like that, like that, like that, like that, like that. Right? Not wrong. But you need to know that this is the same as this. Yeah, this is the same as this. For one guy drop off at the second carbon. Look at here. For one guy branch out from the second carbon. Same height. Important to know the different problem because the O level will ask, I mean MCQ like maybe 1 mark, but still a mark, right? Sure come out one. Okay, must understand, don't understand, ask me, right? So you must know that. So now on this page of my board here, how many isomers are there altogether? Xinjiao? How many isomers are there altogether? Like that. 2, very good. Top one is 1, bottom one is 2. So top one, the 2 same, bottom the 2 same. Right? You cannot say 4 wrong. Must understand, Okay. And of course, I will tell you the last one. So the last one is like that. Right? You make 3, then you make 1 up, 1 down. Okay. Now, so you cannot shift, assuming you say, hey, I want to try like that. I shift it here. Cannot, it's the same. These 3 are the same. Because it's just a like flip it over or mirror image. You understand? You must know that these 3 are the same. Do you understand the same? Okay. Then the last one is okay, I draw properly. The last one is the red one below. I draw again. Make it 3, but don't worry. Okay, this is the first time you try, then you stress. Don't worry. Make sure all the bonds are. Core carbon need to have 4 bonds. Shear heat 12 one. You see? So this entire page, how many isomers? 3 isomers. Just choose any 3 to draw. I mean, the top one choose 1, the middle one choose 1, then the last one. Okay, and Jolie take note, carbon must form 4 bonds, hydrogen must form or can only form 1 bond. You cannot put hydrogen to bond. Any question? Where's 1 minute? So isomers, I say again, they are molecules having the same chemical formula but different structure. Okay, same chemical formula but different structure. Okay, so we are done with that. Now, so the chemical reaction for alkane. So we must know that every homologous series will have their own special or unique. Only combustion is the one that combines. They have their unique reaction. That means alkane undergo combustion, but combustion for everything. So combustion, you write down all organic compounds can undergo combustion. Combustion means what? Burn in oxygen, give out carbon dioxide and water. So alkane also like that, alkene also like that, alcohol also like that, carboxylic also like that, ester also like that. All can undergo combustion. You add O2, produce CO2 and H2O. It's exothermic and hot, burning one. So this is a little bit in air pollution. Incomplete combustion give you what? Soot, which is carbon, the black thing from some of the vehicles, and carbon monoxide. Incomplete combustion. Learn before? Never. Air pollution never learn. Oh, haven't. Okay. Okay. So let's say we burn something at home or in your classroom, you better run away because you are actually taking in carbon monoxide, but you don't know. Because no smell, no taste, no color. So you cannot sleep on the aircon, sleep in the car. People died before because the car never moved, not enough oxygen, the incomplete combustion. But burn something in the open air, never mind, won't die because complete combustion, CO2 we breathe in won't die. CO we breathe in will die. Enclosed area, burning, you better run away or try to put out the fire and then call the fireman. How do you have what? Not enough oxygen or insufficient oxygen limited oxygen. Of course, by looking at that, you cannot see they have to describe to you. Okay, so when there's not enough oxygen, there will be incomplete combustion. When they just say combustion, I assume it's complete. Next one, which is something new, is called substitution. Okay, after this, we take a break, but follow me. Look at the substitution. Memorize UV light. This is the start of all the memory work. Okay, this one, nothing to cannot derive one. You must memorize UV light or sunlight. Who substitute who? Look here. First of all, methane plus chlorine. Wow, can you see? There's a substitution that took place. Who substitute who? The Cl substitute the H, right? Can you see now? This H gone, right? A new guy coming back. It's got substitution. The chlorine substitute the H. Then, of course, got one more Cl there, join HCl. You know what's the funny thing? Can continue, Again, as long as there's UV light, again. Again, correct? Again. Is it again? Can you see? Who substitute? This one. I think. You see not? So the first one, the Cl on the right, there are circle going, substitute the H. The second one, the bottom one, cannot substitute, right? You see not? Can continue or not? Can. Got too much to substitute, So like can substitute 4 times, Everybody, online student understand? Can you see now this guy can substitute again because I can write another equation, right? Can you see? The product can one more time, as long as got UV light. Then now 3 already. You can see now 3 cannot substitute. And, okay, just to be complete, again. Hey, honest student, if you cannot follow or very confused now, stop me. Again, can you see? Then cannot already because there's no more H to be substituted. You must have the flow, right? So every one time, the substitute only one time, understand? Because got some MCQ, they substitute one time, twice. No. Every one step is one H gone, one Cl going. Then that product continue as long as there's UV light and chlorine. You do until no more H to substitute, then you stop, cannot. Maybe you should either squeeze some drawing or notes about this. Yeah, 1,2-dichlorobutane. So you see the word butane. Butane is how many carbon? 4, right? Butane is 4 carbon, right? Butane. So 1,2-dichloro. Di means 2, chloro means Cl, and on 1 and 2. So there's a chlorine here and there's a chlorine here. So this is 1,2-dichlorobutane. Right? This is so the name I know a bit weird. So 1,2-dichlorobutane. So if you say there was another name, if I put a Cl here and a Cl here, it's 1,3 because it's the third one. Correct 1,3-dichlorobutane. Before you continue doing your work, how about this? What's the name for this? What's the name of this? Think I'll try. So on the first and carbon atoms, yes, because 1,2-dichlorobutane. Okay, so Aaron say 3,4-dichlorobutane. Cynthia, what's the answer for this? Again. No, it's also 1,2-dichlorobutane. You know why? Because you must count from the smallest side. And don't you think that this and this, they are the same? Remember just I told you the isomer? Right? It's just a flip, right? So count from the smallest side, important. So just I didn't teach you, I forgot to teach you this part. You understand? So if I give you one more example, no stress, but let's say I give you another example, right? Okay, I'll draw longer, if not, I have nothing to discuss. What's the name for this? I mean, what is the number of this? Very good. 2,4 Dichloro, 1, 2, 3, 4, 5, 6, 7. Heptane. Okay, understand? Last one, before I stop talking, last one. Stress, you see this one, stress. Wow, how? You see the red one? Naming is not a syllabus, but you need to have some knowledge. You see the red one, so fun. Red one, what's the name of the red one? Red one is 2. Okay, okay, good try. Aaron, good try. 2, 3, 3. Because you say trichloro, you need to tell me the position of the 3 again. 1, 2, 3, 4, 5, 6, 7, 8. Understand? So as long as I know it's on the third one, but you need, it can be 2, 3, 3, 2, 3, 2, 2, 3. Understand? So as long as you write trichloro or dichloro, you need to tell me 3 numbers because it's tri. Di is 2. How about 4? Just curious, 4 is called what? 4 is called? So 1 is just chloro something, 2 is dichloro something, 3 is trichloro something, 4 is what? 4 is very good, tetrachloro. Then you need to put 4 numbers there. Okay, some knowledge. And I say naming is not syllabus, but you need the knowledge. So it's so weird. Okay, go back to question. Okay, 5 seconds. I'm going to move. Okay, 20 seconds. As you do more, you get more naming experience. Okay, now just like that first. Okay, those finished can proceed to finish the 4 MCQ. Okay, so the first one, right, as the number of carbon atoms in the homologous series of alkane increase, actually no need alkane, as any homologous series is the same filling, right? Which of the following will decrease? Yeah, which of the following will decrease, means drop. So density, no lah, because you know why? Remember I told you from gas to liquid to solid. So solid, of course, the most dense. So it increase. Number of isomers, I think should be more lah, because more carbon I can go and anyhow arrange, right? No. Viscosity increase. Remember just now? Solid are very viscous. So the answer is flammability, right? Difficult to burn. Okay, easy. Right, this is directly from what I asked you to learn just now, right? Be careful. Now, okay, this is a bit weird, but my practice a bit weird. So excess chlorine. So what's the answer? Tell me, I guess. Okay, D. Okay, this is weird. You know why? Excess chlorine means the reaction keep continuing. Just now, remember I told you I draw until I die. Yeah. So keep continuing because you know why? Excess chlorine. So I assume that there's a lot of chlorine. So it continue until you reach the pink guy below. Understand? Tetrachloro. Okay, but don't worry. A lot of students ask me how I know. They will not be middle one. Understand? It's the extreme end. If it's limited chlorine, then what's the answer? If it's limited. Yes. So if it's limited chlorine, then you put A because a bit of chlorine only one guy substituted. This is all 4 substitute a tetra. Okay. Which of following is not a product? So not a product. So this one a bit headache. You must be very clear of the reaction that I draw 4 times just now. Answer is, Aaron, what's the answer for number 7? I'm curious. Not a product for the substitution process. Very good. A, there is no hydrogen. Just now I draw the 4 rate of H2, right? There's HCl, maybe sub 1, then sub 2. Can sub 3, can sub 4. And I got to tell you that, okay, this is a bit more like A level or even in uni. This is a very random substitution. That means I don't know one. I cannot control that. Oh, I want that. It's a random thing happening. Okay, so but what you learn at textbook only one time. But you must know you can continue one. Okay, as long as there's chlorine and UV light. But hydrogen gas don't have. Right equation where got hydrogen gas, you see? No H2 one, right? Every equation is the guy and HCl, 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 okay? HCl, 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 HCl. Last one a bit weird, okay? So you know, our UV light, so it's under alkane. Okay, so it's under alkane. So this one and this one. Because this is an alkene, this is an alkene. Can you see? Yeah, but these are a bit weird because you never learned alkene yet. Because alkane is CnH2n plus 2. Then remember I told you, one reaction is always sub one time. So answer is C. But, okay, just know this first. I'm going to tell you something weird. Okay, I see very difficult question. Alkene also can, anything actually can undergo substitution, but that's next time. But for now, is alkane undergo substitution? Okay, but actually I can argue and choose. To be honest, I can argue and choose B also. Because by right, alkene also can undergo substitution, but that one higher level or weird. Okay, so for now, your brain, alkane undergo substitution first. Understand? Any questions? That's 1 minute. So the next homologous series is called alkenes. You understand what I'm saying? The next homologous series is called alkene. Just now was alkane, different, So the general formula, of course, different because it's a new guy, new family, like mammals, reptile, fish, maybe such thing. You understand what I'm saying? So it's a new general formula. Just now was +2, now it's 2n. Just now was 2n plus 2, now it's CnH2n. Just now was saturated, now is unsaturated. Means carbon-carbon double bond for this case, okay? So unsaturated means carbon-carbon double bond. I mean, you want to spell out, because this dash is very confusing, it's not a bond, right? So I prefer to tell you like that. Carbon dash carbon double bond. This I need a double bond, Unsaturated means carbon-carbon double bond or even multiple bonds, but for O level only double bond. Saturated means single bond. Just now was saturated hydrocarbon. Hydrocarbon means made of carbon and hydrogen. This is unsaturated. Okay, so the first member of alkene cannot be methane. I say again, just now methane can, but this one cannot methane. Why? Why cannot methane? Yes. Why cannot one carbon? Because how you use one carbon to form a double bond? A double bond need 2 carbon, right? A double bond need minimum a carbon double bond need 2 carbon, right? But just not can because I just need no need double bond, right? No need single bond, or in other words, actually no double bond. Okay. Yeah. So this one mean first guy is called ethene already. Okay, so be careful, right? Ethene, so ethene, be careful. So I teach you how to draw double bond. Carbon need to form 4 bonds. So 1H, 2H, 3H, 4H. This is called ethene. Propene, double bond. 1H, 2H, 3H, 4H, 5H, 6H. You understand? Then you will feel weird at the start, but afterwards it's easy. Just make a double bond present, then make sure carbon form 4 bonds. Okay. The 4 bond no need to be around it, can 2 bonds like that, it's called 2A. Only 1 double bond needed for the alkene. Means I can draw like that. I just need 1. I mean, an alkene can multiple, but that's later on. But for now, you take it as 1 double bond first. Later, I teach you more than 1 double bond. That's other question already. Okay, but the drawing, be careful. Make sure every carbon, 4 bonds. Then the number will add up. Look at the last one, so complicated. 1, 2, 3, 4, 5. 1, 2, 3, 4. C6, remember, alkene got to be 12. 2N. Right, CnH2n, 12. Which 12 now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I just now when I draw, I never even bother. Wow, must have 12. I just draw 1 carbon, 4 bond, everything. Okay. Understand? Same thing lah. Physical property, like just now, like physical properties. Exactly the same. 3 of them. Okay, right? Same thing. Then melting molecule increase because larger molecule viscosity increase, flammability decrease, same from gas to liquid to solid. It's just that this one there's no methane. Just know that. Okay. Now, first reaction of the day, cracking. Okay, everything all right. So just now we learned combustion and substitution. Now we learn cracking. We can actually this section should be placed in alkane. I don't know why last time I put here, right? But anyway, I have put here because it forms an alkene. So a large alkane crack to form smaller alkane and smaller alkene. Means what? I give you a big alkane, I break down into smaller parts, any number you like. As long as you add up, as long as the H and the C add up is correct. And how to do that? Make sure one is alkane, one is alkene. Or actually rephrase, I can have many alkane, many alkene. Make sure you add up to the original H and C there. Means what? Means what? Look here. C 100, H 202. Must be an alkane at the start. First guy is the alkane. Break into any number you like lah. C, any number you like. I mean, they will guide you, not any number, but the question will guide C10 cannot. H 20. Maybe C 22, H 44, or anything. Put an alkane in. Okay, let me conclude. Let's say I cannot. 32, 68. I make my life very difficult, right? Okay, 68. So let's say this is an alkene, right? 2N, CH2N, alkene. This is an alkane. So it's what? 68 times 2 is what? 136, right? 138. 19 is the number add up, right?
Why is that for
can also, anything, 10 also. So anything, what I'm trying to say is that all must add up to the first one. This one must be an alkane. This one I cannot run away. It must be an alkane. You can only crack alkanes. Okay, I also don't know why, like just like that. But what I'm trying to tell you is that no need. Because a lot of students when I teach this, they say, okay, no, I will force out only one. No need. I can many. I said, just add up. The question will guide you practice more. But your job, now, give you 1 minute. Can you memorize these 3 things? So 600 degrees Celsius, SiO2 and Al2O3 catalysts. You need to memorize these conditions. The 2 catalysts and the temperature. Can you do that now for cracking? So combustion is still the same. Remember I told you everything under combustion, but what I write here? Did I teach you before? The shortcut C3H6 plus O2 give you CO2 plus H2O. Okay, everybody listen. It's a technique that can be used for other things. Balance, right? So we balance the carbon. Then we balance the hydrogen, right? Then we check right side, how many O? 9 O, right? Right side got 9 O. Left side got 2 O. Odd number how? I teach you. 9 over 2, can? Right? It's like math, right? 9 over 2. But A level, you are supposed to do it this way. But O level cannot. So can we multiply by 2 throughout? Multiply by 2 throughout, can? So, end up is this there. 2, 9, 6, 6. You understand?
So this is like
final. The on top of the working. I teach you the half method. So as long as you meet a situation of odd number that on the left side is a diatomic, like N2O2 or anything 2, then you go and halve it because you 9 over 2O2 is 9O. Do you understand, everybody? And then multiply by 2 throughout. It's just a technique. Okay, online student understand. This one also used in what's it called? Air pollution. Okay, but next time I teach you that. Okay, understand? Okay, the last thing will be, okay, this is the main part of alkenes. Okay, everything main, but this is the very main part of alkenes. is called addition. For alkane, we analyze substitution. For alkene, we analyze or they undergo addition. So addition means what? Actually, if you look at this whole page, it's the same, right? Can you spot a pattern? These three, there's a similarity. Can all of you tell me a pattern before I continue? 4 bonds. Okay, not that. Not 2 carbon. I show you. Look at these three. When the reaction proceeds, do you agree that I break my double bond? One of my double bond, right? Break, break, break. And form. Can you see? Can you see now? So the addition reaction is breaking one of the double bond and form 2 new bonds for this guy to be added, this guy to be added, this guy to be added. Please try to understand this because it's the same. A lot of students say, wow, so many reactions. No, to me, all is one. Okay, I know got different conditions, but at least you know that they all belong to addition. Break one of the double bond, form 2 new bonds for the 2 new guys to come in. Okay? I mean, one guy, but it's just like Br2, there's a 2 atom. But the water is H and OH. So Br is Br dash Br, right? H is H dash H. Water or steam is HOH. Another similarity for this as compared to substitution is what? What is the meaning of substitution? Like a soccer match, right? What is substitution? One guy go in, one guy come out, right? But what is addition? 2 guys form 1, right? Right? Must know also because you need to know this because the database is quite tough sometimes. So addition is I add in, so 2 become 1. But substitution, they're not 2 and 2, right? Because you need to go in 1 player, come out 1 player. But this is 2 become 1. This is something you need to spot also. 2 become 1, eh? 2 add together become 1. 2 reactant become 1 product. Right? But substitution is what? 2 become 2, right? So substitution is 2 to 2. This is 2 to 1. Okay, don't worry, practice again. Let's go. Finishing. Bear with me. First one is called addition of bromine, or some school allow halogenation, or some school allow bromination. Depend on the school, very scary. Some schools say addition of bromine. Oh, so difficult. Addition of bromine is the best answer, I feel. But A level is all like addition of something. One. Memorize. Bromine added in. Memorize now. Room temperature and pressure is the condition. It's like nothing, but you cannot say nothing. Okay? So when you bubble bromine, depending, okay, normally we can say bromine liquid. When we add bromine liquid inside, it will decolorize. Oh, sorry, rephrase. I bubble ethene gas, ethene is a gas, into bromine liquid. It will decolorize because bromine liquid is what? Reddish brown, right? Remember you learned in the group 7. Reddish brown liquid, right, will decolorize. So this is a distinguishing test. To tell me that there's alkene present. I say again, important. Okay, listen, 2 test tubes. One is alkene, one is alkane. I add bromine. Only the alkene will, this is reddish brown for both. But when you add inside, colorless. I add inside, cannot react, so it remains reddish brown. You understand? I got properly. So this is alkene, because can react, so the bromine gone. Alkane cannot react, the bromine remain. When you can react, the reddish brown gone. It's called decolorize. So this is a very powerful distinguishing test to tell you is it an alkane or is it alkene or is it other things, or whether got alkenes present. Yeah. Second one, so only the first one is distinguishing test. Because the other two got no color change and blah blah blah. So second one is called addition of hydrogen. So last time some school allow halogenation, hydrogenation, and hydration. But safer, you write addition of bromine, addition of hydrogen, addition of steam. Memorize nickel catalyst at 200 degrees. Room temperature pressure on top. Nickel catalyst at 200 degrees. Last one, the most irritating of all, addition of steam. The condition very funny. 300 degrees, 60 atm, phosphoric acid, H3PO4. You need to memorize the conditions, cannot change one again. Okay, some school write phosphoric 5 acid because the charge of the phosphorus is +5. You do the redox. So if you look at it again, they are the same. Okay, the three of them are the same. Okay, just curious, right? Can you tell me the answer? Aaron and Jolie, can you type there for question 9? What's the answer for question 9? What's the answer for question 9? Okay, what's the answer for question 9? See, everybody different, right? Everybody different. Okay, Jolie, what's the answer for question 9? What do you write as the answer for question 9? Hey, Jolie, are you there? What's the question? What's the answer for question 9? A, okay. Aaron, D, okay. Cynthia, what? B, okay, all different. Okay, now listen to me. Whenever you do addition, so C4H8 is double bond, is an alkene, right? So chlorine being added inside, it has to be adjacent. Adjacent carbon means the chlorine got to be side by side. Cannot be A because there's only one chlorine, need to be 2. Cannot be C because cannot be on top and below. On top and below is the same C. Cannot be B. Cannot be B because cannot skip. Okay? You are skipping because the double side by side. Answer D. There's A. How come it's D? Because if I redraw, remember, right? One, break the double bond. One on here, it is the same lah. You understand not? Right? Up, down, left, right is the same. My concern is that the chlorine or the newly added atoms has to be side by side carbon. Is it not? Side by side. Attached to the side by side. But up, down, left, right doesn't matter. Right. It can be here, it can be here, doesn't matter. It can be here, doesn't matter. It can be here and it just need to be it just has to be adjacent carbon. This statement. So Aaron, very good. Okay, so remember addition is always side by side. Okay, substitution no issue anywhere, random, I told you. Number 10. Wow, this one need to memorize. Wow. So pentene, add in, so pentene is a double bond, 5, right? Later on, we form H and OH, right? So B, pentanol. It becomes an alcohol. You understand like just now? Okay, so when we learn alcohol, then you know the naming was the same. Instead of pentene or pentane, it's a pentanol. If it's carboxylic acid, pentanoic acid, like the same one. Remember I tell you the prefix follow. Okay. Number 11, very irritating. You know how to do number 11? You try to do trial and error lah. A bit lame right? There's no way to. I mean, A level there's a way to do algebra, but no need lah. Try error lah. You know, I just try. Can I try the last one? C4, page 10, plus O2. Give you CO2 plus H2O. I try to see if I can work. 4, 5. Okay, 4 times 2, 8 plus 5, wrong already. This 13/2, wrong already. So not D. Because you want 1 mole or 1 volume or 5 volume, this mole lah. C3, because they are gases, remember gases, mole ratio is volume ratio. So I try 3, I try 4, 10, 5. Yeah, this answer, C. Okay. So you must know that the volume ratio is mole ratio, okay, for gases. 1:5. So answer is C. They cannot set liquid, so I assume the ABC, they are all gases. If it's a liquid or solid, you cannot volume ratio, it's mole ratio. Okay. Number 12, isomers. So same molecular formula, different structure. Yeah, easy lah. That's all. That's the main difference, right? The main similarity. Right? The molecular formula same is like C4H10, C4H10. That's the molecular formula. But the structure is different. 13, super important. Yeah? Before I do 13, I tell you something. Do you agree that this is C4H10? Sorry. C4H8, right? C4H8, right? This is also C4H8, right? This is also C4H8, right? First one is an alkene. Alkene. Because no double bond. So this is a unique thing only in A level you learn, but you can set here. It's a ring structure. The formula feels like alkene, but it's alkene. There's no double bond. And this is alkene. And this is alkene. Because you need double bond. Okay, so you learn something new today. This is a cyclic compound. Follow like alkene, but it's an alkane.
Is it on the cyclic compounds you for the first one?
Yes, there is a ring. Round. I said, like cyclic, you mean like when it's a ring. Let's say I want 6, right? Then I draw 6 ring. You understand? 1, 2, 3, 4. So ring, cyclic. Molecular same? Same. Same Homologous series? No, because one is alkene, one is alkane, 2 alkene. Isomers? Yes. They are isomers, right? All C4H8. So you learn something from this thing also. Isomers no need to be all alkene or alkene. Most of the time it is. But this is alkene. Right? Follow the definition, right? Same molecular formula, different structure. So alkene also got isomer. I show you something. This is an isomer because okay like H. Can you see? So the H actually very complicated. I don't like to draw, but anyway, I draw for you. Can you see that these two are isomers? You know why? The double bond different space, right? The first one is which space? Number what? Number 1. Let's see this first. Second one, number 2, right? So the name, I tell you the name, but don't wake me up. 1, 2, 3, 4, 5. It's called pen 1 in. This is pen 2 in. Okay. What if I draw the next one? What's the name for this? No, also pen 2 in. Remember, count the smaller side. This is it. First space, second space. Okay. Okay, don't worry so much. So actually, this and this, they are pen 2 in. Count smaller side, left or right. Organic chem all like that on the field. But I say, don't be so stressed. You move as you go. So when double bond is at a different position, it's a new isomer really, because the formula says C5H10. Okay, honest student, understand? Don't understand, ask me.